Hi and welcome back. In this video, let's cover how to make a bolt. And what you see on your screen is a typical 1/4 inch diameter bolt with an inch length of threads. Should be 20 threads per inch. And you should see this is a 7/16 inch wrench that you use to turn it. And this bolt is even complete with the chamfer in this section here so that the threads end without digging into the head, and the corners are chamfered here at the top so it doesn't catch on your wrench, and to make threading it into a nut easier, the end is chamfered on an angle. We're going to do all that. So let's set this one aside and start a new sketch. Now, in this sketch, what's going to be very different than what we're used to. We're used to working in metric all the time, standard metric. Going to make an exception this time. We're going to switch over to English right here. And we'll do standard inch imperial measurement. And we'll go ahead and create it. Okay, so we have our new tab open. The old one's here just in case we need to refer back to it. So let's begin. And I think the easiest way to begin on designing this is from the head out towards the threads. We'll get the head done first. So basically we will design this bolt kind of upside down like this. So that's the way we'll design. We'll start down here and work our way this way from the bottom up. Let's begin. Start a 2-dimensional sketch. We'll choose the build plate, of course. And let's take some shortcuts. Normally you have rectangle chosen up here. I'm going to choose polygon, and a 6-sided polygon is perfect. So let's find our center dot, click on it, and bring out our head to the bolt. Okay, we're done drawing hexagons. But oh yeah, of course I always forgot to do this part. There we go. So let's make it perpendicular to the x-axis. So we'll choose this line here, and look at that, it did it. So now this is straight across, which means these points will now lie on this axis here. That'll make drawing much easier. Okay, so we'll finish that sketch, and I think it would be a good idea at this point to make our 3 axes visible. So I'll just right click on it and say visibility for the X, visibility for the Y, and visibility for the Z, because we're going to refer to these from time to time. Okay, so what I forgot to do is, how big is that head? Well, no problem. Let's right click on our sketch and edit it, and zoom that out, and let's dimension it. The side to side, the width across the flats is 7/16 of an inch. So from that side to that side, it should be 7/16 of an inch. Let's do that. From this side to that side, we'll click on it a couple times, and we'll go, and I love this, 7/16, and I'll even throw an inch just for grins. This will do the math for you. So 7/16 of an inch. Okay, now we can finish our sketch. Now let's extrude upwards And I believe we are looking for the head height, which is 3/16 of an inch. Alright, so let's make it 3/16 of an inch tall. We shall, of course, hit extrude. And it chose the head for us, and it made it an inch tall. Too tall. Not a problem. We'll change that to 3/16. 3 divided by 16 inches. That looks more like it, so we'll OK it. Great. So now we have the head, except we need to chamfer these corners, knock them down. This is the head of the bolt, by the way. This is the way we are building upwards. But we're just going to visit this bottom here one time. We're going to knock these corners down so that they look more like this. See how they're tapered? Now, a neat way to do this, you notice there's a circle on the top here. That's a trick. Let's go back, and we are looking at the build plate bottom of this, and let's sketch on it. So we'll just choose it. We'll hit start a 2D sketch, and let's draw a circle. How big of a circle? Well, start in the center, work your way to the flat until you see perfect the extrusion from a circle to a flat line. That would be this one right here. That would be the tangent constraint. So now it's constrained out, and we are finished with that part. And we're going to tip it down a little bit. And now we're going to use the extrude command in a creative way. So I'll click extrude. Of course, it wants to build on it. What we want to do is flip it the other direction, and we want to taper it 45 degrees. And what that's doing right now is it's doing a cut or remove of material, except for what we've not touched, which is the part we really do want to remove. No problem. We have something here called intersect. So when I click on intersect, now what we have is everything that this cone covers will be included, and everything outside of the cone, namely all these corners, are now excluded. But here's something you need to know about this command, is if you don't make it tall enough, you don't get the whole head. So how tall to make it? Well, we have a fancy command here called to. You click on it and select a face. We want to go all the way, including the bottom of that, and then pretty much no further. So I click on that and look at that. There they are. Perfect. We got the whole head. We'll OK it. There. Now that looks a lot like that. Okay, let's roll it over and keep drawing. So now we got to do the shaft of this thing, and that is a 1/4 inch diameter. So let's draw ourselves a 1/4 inch circle that we can extrude. We'll start off by selecting that surface there, because that's where we want to build from. Go into 2-dimensional sketch, grab the circle command right there and click on it. Bring it down to the center, click, come out. That's about a 1/4 inch, somewhere in the area. We will use the dimension tool here to make sure that it is. Okay, so it is 0.254, 1 divided by 4 inches. There you go, 1/4 inch. So let's roll it over and finish our sketch, because we're done drawing circles. And now let's make it an inch tall, because this length we want it to be a 1-inch length. That would be what we're after. A 1-inch bolt. Okay, so let's go back to it. Hit extrude. Tell it to be 1 inch, 1 inch, and okay. So now we're getting the raw materials in place. It's looking pretty good. Alright, 2 things we need to do to make life easier is, in the original, in this bolt here, there are 2 chamfers to deal with. There's one up here at the top. It kind of angles like this to make it easier to start it in the hole. And there is this one right here. And that one keeps us from gouging the threads into the head for maximum strength. Alright, because we'll thread up to it, but not into the head itself. So that all of this head will be solid. Alright, so we'll go back here. And what we need to do now is go and look up. Oh, and I will show you this here. Right here, this link right here, the theoreticalmachinist.com/threads_unifiedimperial.aspx. That address right there has a really good web page for designing for threading threads. It has a calculator, and it also shows you down here what these items represent. So the things that we want to worry about the most is, let's first pick from the calculator, 1/4 inch bolt with 20. A 1/4 inch -20 UNC means a 1/4 inch bolt with 20 threads per inch. We'll hit compute. And when you hit compute, it fills out this thread data section right here. Okay, good. So, the things we concern ourselves with that thread section is this, hang on right here. The things we want to worry about, because there's a lot here, is we need to worry about pitch, which is right here. Pitch is the distance between threads, essentially. Thread depth, how deep to make the thread that you cut into it. How deep the, basically how deep these grooves are. Here, we'll draw the line a little bit better just because it's picky. Okay. And something called the root flat right here. The root flat, now you can see the numbers. Well, anyway, the root flat, that is the distance at the end that you chop off the triangle that cuts these threads. Makes a little flat. It's not a solid point, because if you did a solid point, there'd be almost no tolerance for being able to thread these. They have to have some slack, and the root flat allows for some of that. Okay, so those are the items we're going to concern ourselves with in this calculator. Alright, so now that we've hit compute, we've computed a 1/4 inch by 20 threads per inch standard thread. The first thing we're going to worry about is the thread depth. And the thread depth, again, is how deep these grooves are, because we're going to draw a triangle. And one thing to point out to you here too Every thread you ever see is a 60-degree angle. Okay, keep that in mind. It's a 60-degree angle. Basically, it's a equilateral triangle. So every angle on that triangle is 60 degrees. It ends up being a total of 180, which is all the degrees you get in a triangle if you do the geometry. But the important thing is a 60-degree angle that you use to cut your threads with. Almost always, I've never seen anything different, which is excellent. There's a standard. Okay, so back. We'll set ourselves up for that. First, let's take care of some head things. Chamfer. That distance right there looks okay. That's about 1/8 of an inch, I believe. Oh, no, no, no. Goodness. Too much. How about let's make it 1/64 of an inch. That's not enough. Let's make it 1/32 of an inch. That's better. How about 1/16 of an inch? A little too much. How about 3/32 of an inch? Ooh. About 3/64. I like it. 3/64 looks like a winner. Okay. So we've taken care of the chamfer up there. And let's put that little fancy groove thing down here that we were looking for. And I think what I'll do is use the thread depth that we have on our chart here. The thread depth is 0.0365. We're going to go with the left-hand numbers on all of these. There's a range, but I'm going to use the left-hand side for all my measurements. You can see I can go as high as that or as low as that. So I'll just go for the gusto. 0.0365. There. Wrote it down. Back to here. So, I'm going to design myself a triangle. And let's zoom out. And let's pick a plane right there and make that visible so we can see it and we can draw on it. Perfect. So we're going to draw ourselves a little triangle, or we can be fancy and make ourselves a triangle. And I want it to go in like that. Something like that. Oh, we're done drawing triangles. And I want it to be from here to here. I want that dimension to be, let's say 0.0365 inches. Guessed it pretty close, it looks like. And then I want this tip of the triangle to come right in this corner here. Right into there. Oh. Now, and then I want this to go right into it, so it cuts into it. And instead of threading it upwards following a pitch, I'm going to have it revolve around here at 360 degrees. So it gives us a base, a tapered base. Alright, let's throw that in there. So let's turn off the dimensions by hitting escape, because that's dimensioned. That is a 60-degree angle, by the way, by using a equilateral triangle. Those are all 60-degree angles. Every side is equal to the other side. Let's constrain it. So we can use this constrain command right. Oh, before we constrain it, let's project our geometry. So we want a line there, and we want a base here to come down to. Okay, so we have that, and that's what we're going to shoot for. So first thing we're going to do is constrain the this bottom here down to this line here. And the second one, we'll constrain that line to that line. We'll do it in that order so we can still see it. Alright, here we go. Begin with, let's use coincident constraint. Put that dot to that line right there. Perfect, because we don't want to go any deeper now. And then let's constrain that line there to that line. Oh, I don't have a line, so let's go with this one. That line to that line. Perfect. It's buried right in there. So I'm going to go ahead and say finish sketch, even though you can't see it very well. It's in there. We'll just have a little faith that we are clicked on it, and we are, because sketch 4 is that. And that's one way to tell. You just click on the sketch and you can see it embedded right in there. Alright, let's revolve it. So we click on revolve. It's already picked our profile, our sketch 4. We need an axis to revolve around, which would be down here. That's why we made those visible. And now it's revolving, but it's not cutting, it's adding. Those make it cut. That's exactly what we wanted right there. Okay. So now we have our revolved tapered base. Okay. We'll leave this plane visible because now we need to put a cutting tool in and cut down and make threads. So let's design a cutting tool. This, by the way, that triangle we just did is almost perfect for a cutting tool. So let's do that. Alright, so we'll pick that plane that we were just working on and we'll go into sketch and we'll slide it down. And you know, we can go two different directions. I often like to go from the top. But I think I'm going to cheat it this time and I'm going to go from the bottom. So let's do it the polygon way. So we'll draw ourselves a triangle, and that's the triangle we want. We'll dimension it the same as the other one, and I believe it was 0.0365. So that should match. So if I were to take and move this whole triangle over, okay. Yeah, it is constrained. Okay. So we'll put this line here to this line here if we can. We'll project our geometry. And this line here to this line here. If we can get... Alright, let's see if we can constrain it. So that line, we'll choose that line and that line. And then we'll choose that line and that line. Perfect. That's what we want. So now we can finish our sketch. And let's go to our coil command. So coil requires a profile, which was sketch 5. Looks like it chose it for us, as it often does. It requires an axis to revolve around, which happens to be handy right here. And looks like it's doing a seriously tall coil. So now we are going to switch over to pitch and height. Since we know what the pitch is, our web page. So pitch is 0.050. We'll copy that and we'll paste it right in. So pitch is, there we go, and height is 1 inch. And look, it comes out about right. So we'll OK it. Oh, and of course, if you do that and it looks like that, it means you forgot to tell it edit feature, I forgot to tell it to remove, which is what that command right there does, is cut. That is better. And that looks like a completed bolt. But there's something wrong. If we zoom in, these shapes, those flats, are not flat. They're all like these outside flats right here. You notice there is a small flat area where it's not pointed. And this one is. This one needs to be like this. So let's adjust our sketch and fix that. Now, where that is, it's our cutting tool. It's a perfect triangle, except it needs to have a chamfered end. And let's go find it and fix it. I believe, well, we can just move this. Oh, it's in the coil command. There we go. So we'll just right click in coil, and we'll say edit the sketch. And there's our triangle. Interesting how it rotated it the opposite of the way we designed it, because I do believe we were on the left side. So what the problem is we need a little chamfer right there. How much chamfer? Well, we need a root flat, it is called, of 0.0099. 0099 inches. Pretty small. So let's see if we could make a pretty small one right here. One way we can do it is, normally you have up here a fillet command. And I have practiced with this earlier. There's a little drop box right here. If you click on the drop box, you can get to chamfer, which I recommend. And then in that distance, you can put in 0.0099 inches. And don't hit OK, because that will just close this out. What you do next is you choose where that's going to go. And we want to choose here. Click on that line. Down here, click on that line. And look, it added that line right there. There's our chamfer. Now we can OK it. And now we can finish our sketch. And with the magic of parametric design, look at that. We've added our flat, our root flat. And now it matches this. So the technical terms for those. And it would be a crest flat and a root flat. So root flat is down in the valley. A crest flat is what's on top of the, essentially the hill. There's your crest flat. There's your root flat. And through the magic of math, it came out. So there, that should be your bolt from start to finish. Now you are able to make fasteners for your projects. Albeit probably not that strong, but you know, if you ever find yourself with a metal 3D printer, they will be strong. But as far as for making things like mounts for cameras and different low tension designs, these are strong enough. Remarkably strong. So there you go. I hope you enjoyed the video.